We're going to finish up our last section with solving rational inequalities. We're dealing with inequalities. So the thought process is this. Not only are we going to find where, if we reread this, think about numbers that are greater than or equal to 0 would be positives. Positive numbers are bigger than 0, but they could also equal 0. Now here's where we have an issue, is we also have an issue that we could be undefined. So if we looked at this problem and we just answered the first question, x minus 5 divided by x plus 3, when could we equal 0? Well, things equal 0 when you do 0 divided by some number. I'll even write out some number. Sometimes in math you'll see 0 divided by some c value, some constant, because it doesn't matter what that constant is. So in other words, this thing can only equal 0 if the numerator equals 0. And I'll write that out. When the numerator I'll just write equals 0. Because at this point you could just add 5 over and you could say x equals 5, and like we said, it's positive or equal to 0. So is this part of the solution set? Yes. Now here's the flip side of it. Where are we undefined? Well, we are undefined when the denominator equals 0. Because we can't divide by 0. So in this problem, we're just setting the x plus 3 part equal to 0. So if I subtract that 3 over, I get x equals negative 3. And this time, no, it is not part of the solution set. Because if x equals negative 3, your calculator will say no solution. If I go to a calculator and I'll type in negative 3 in for both those x's, and negative 3 plus 3, your calculator even says when I hit enter, divide by 0, that's an error. You can't do it. But if I go back to that problem, let's go back to it and change those 3's to 5's, now your calculator is going to say, yeah, that's not a problem. Because if I plug in 5, I get 0 divided by 8, which is 0. So that's the big difference between those two. And so in the next part, it just asks you to plug it into your calculator and plot the solution on a number line. So what I'm going to do is go to y equals, that button on my calculator, and type that in. And see if you remember when we talked about this from a long time ago. X, I already forgot what it was. It must have been minus 5, and then x plus 3. There it is. I can see it now. And so when I go to the graph, what I'm really concerned about is where, well, let's think about it. It said greater than or equal to 0 was part of the problem, and those are positives. And I'm concerned about my y values being positive, so that would be on or above. Let me write it down. Y equals 0, greater than or equal to 0. On or above, when does y equal 0? The x-axis. So when you circle that, that's what I'm looking for. So if I go back to my graphing calculator, definitely above the x-axis until I get to negative 3, and not again until 1, 2, 3, 4, 5. So if you look at a number line, it was on or above the x-axis at negative 3. I'm going to put an open circle here because remember earlier it couldn't equal negative 3. And then at 1, 2, 3, 4, 5, and I'm going to put a closed circle at 5 because yes, it could equal 5, and it was above the x-axis to the right. Now I'm going to follow these directions because it says in set builder notation. And so in set builder notation, I'm more concerned about you writing x is less than negative 3 or x is greater than or equal to 5. But you may remember in set builder notation we have this fancy language. It's like a math language in front. But I'm more concerned about you getting the correct interval in here. Make sure, if you have questions, make sure you write them down and bring them to class. And maybe one more reminder is interval notation. because you can also see interval notation, and then the union symbol for or, the bracket with 5 to infinity. So those are both acceptable forms to do this problem. Anytime we compare something to 0, we call those critical values. So if I look at the next problem and I ask you to solve this, what's nice about this one is because it's just less than 0, those are only negative numbers. We don't have to worry about will it ever equal 0. So in interval notation, because I like interval notation, but I'll go ahead and do the set builder notation as well. But in interval notation, it would be all parentheses. So anyway, what you need to do in this problem is go ahead and write out the factored form. So what are factors of 4? What add to be 3? Oops, that's not a factor of 4. But 4 is 4 minus 1. So on top we have x plus 4, x minus 1. And on bottom we have factors of 9 that add to be negative 6. And that would be x minus 3, x minus 3. And so what we can do is we can draw out a number line with our critical numbers. And remember, this zeros or the critical values are the opposite of what we have. So we're going to have one at negative 4, at positive 1, and at positive 3. I'll go ahead and put 0 somewhere in here, just sort of a reference. Very poorly drawn. But they're all going to be open circles because of it's not equal to. Let me write that down. Not equal to. So all parentheses. And sometimes what I'll do is I'll just ask students to guess numbers, like x equals negative 10. Well, if you plug in negative 10, that's a number to the left of negative 4. Negative 10 plus 4 is a negative number. Negative 10 minus 1 is a negative number. And negative 10 minus 3, we get 2 more negatives. Well, what happens if we have 4 negatives? Well, 4 negatives is a positive number. Negative times a negative. Negative times a negative. Positive over a positive. I don't know how else to explain it, but and we didn't want positive numbers because we wanted numbers less than 0. So we don't want answers there. So the next easiest one would be like x equals 0. That's a number between negative 4 and 1. Well, 0 plus 4 is a positive, but these other 3 stay negative. So if you look at that, we have a negative on top, just kind of jotting down thoughts, and a positive on bottom. A negative times a negative is positive, and a negative divided by a positive is negative. That's what we wanted. So our answer is going to be between those two. So let's try x equals 2. All right, so 2 plus 4 is still positive. 2 minus 1 is now positive. 2 minus 3 is negative 1. 2 minus 3 is negative 1. And then negative times a negative is positive. We're back to this situation. And a positive divided by a positive is positive. We don't want that. But then we can try again at number bigger than 3. Any number bigger than 3. Let's try 10. 10 plus 4 is a positive. 10 minus 1 is a positive. 10 minus 3 is a positive. 10 minus 3 is a positive. Oh, we get a bunch of positives again. So we don't want that answer. So the answer that we want are all values for x between negative 4 and smaller than 1. Again, with set builder notation, you might get used to this fancy language, but I'm mostly concerned about this, or interval notation to look something like this. Not the easiest stuff, but certainly doable. And feel free to write down questions and come back at me, because the next one's going with interval notation. And there's lots of ways of doing this. I'm just sort of stuck in my ways on how I want you to do things. Because what you want to do first is compare this number to 0. So that's why I'm going to subtract 3 over. And then while I'm at it, I also want to get the same denominator. I can't really see that color. Let's do a different color. So what I need to do is get the same denominator of x plus 2, which is only acceptable if I also multiply the top by x plus 2. So now I have the same denominator. And what I have to make sure to do is distribute the negative 3 to each person. So it's x minus 3x, which is negative 2x. And then negative 3 times 2 will give me negative 6. And so as I compare these numbers to 0, let's kind of scratch work. Set the numerator equal to 0, and you get 6 divided by negative 2 would give me negative 3. Same thing with the denominator. If I set that equal to 0, so that's a critical number, Cn, critical number. Same thing, set x plus 2 equal to 0, and you get x equals negative 2 as your all other critical number. So again, as I'm drawing a number line, this is going to be a little bit tougher to see because they're right next to each other, negative 2 and negative 3. This time, it's okay for the numerator to equal 0. So the critical number that was in the numerator can equal, but the critical number in the denominator cannot because it's undefined. Maybe I'll jot that down. So the numerator equal to 0, okay, check mark. But the denominator equal to 0 is not okay. X through that thing. So same thing as before, just guess random numbers. Like guess negative 10 and plug it in. Well, negative 2 times negative 10 is positive 20 minus 6 is 14. I just care that it's a positive number. And negative 10 plus 2 is a negative number, negative 8. But a positive divided by negative is negative. Did I want negative numbers? I sure did. You could try negative 2.5 as well. Negative 2.5 plus 2 is still negative. Negative 2 times negative 2.5, kind of tough to do, but it is positive 5 minus 6 is a negative number. So you do get a negative over a negative. We don't want that because that's equal to a positive. We don't want positive numbers because positives are bigger than 0. So try a number like x equals 0. Well, 0 minus 6 is a negative. And 0 plus 2 is a positive. And a negative divided by a positive is a negative number. Kind of ran out of space. So we do want those answers over there. So in interval notation, we would go from negative infinity to negative 3, union, parenthesis, going from negative 2 and infinitely to the right. Notice the parentheses and the brackets. Like I said, this is not the easiest stuff. So if you have a question, you're going to have to write it down and come back and let me know. And some problems are pretty complicated, which is why there's a lot of space here. So something like this, what you're going to see me do is try to get the same denominator as well as moving things over, like 2x, x plus 3 would be the same denominator. I guess what I'm thinking out loud about is moving that 3 halves to the left side, so now it's less than 0. So to get the same denominator, we already have an x, so I have to multiply this top thing by not just 2, but also x plus 3. So as I distribute in there, x squared, so it'd be 2x squared. What else do we have? The negative x plus 3x is 2x, so 4x once you distribute the 2. Negative 3 times that 2 would be negative 6. So then looking at the next one, you got to multiply top and bottom by 2x. Well, that's pretty easy because you just distribute in that 2x squared plus 4x. Oh, and this last one, not so easy because you have to multiply by x and x plus 3. Oh, I know there's a break in the action here, but I forgot to make that a minus 3 in front. So that'll fix right here. There we go. I'm trying to make this video somewhat decent, but I'm sure 2 plus 2 minus 3 is 1x squared, 4x, 8x, that makes it a negative 1x there, and then a minus 6. So on top, you can actually factor that 3, let's see, it would be negative 3 plus 2. So when I factor, what we have on top is x minus 3, x plus 2, and on bottom you still have a 2x, x plus 3. And this might seem like magic, but there's another way that you could approach these problems, and it's called a sign chart. And with a lot of practice, this will make sense. But I'm just jumping to the right answer because of time. And you just put zeros in here, and this only works if you have positive leading coefficients. Negatives to the left and then there's 4 negatives is positive 3